Today I'm going to look at a new spot welder by DOCREATE. This is the model TK10A. It's a battery-powered spot welder for building lithium battery packs, attaching the tabs to them. And this should do a nice job, but a word of warning, when you're working with lithium cells, ultimate care is needed because these things are flammable. They can blow up just like that. In fact, I'm thinking of changing my channel name to Electro Boomer. What is that? This is a spot welding machine. Welding current is 1200 amps maximum, and it uses a Type C USB input, 5 volts, 2.1 amp, and has a Type A USB output. So it looks like it's a power bank as well. Well, let's open it up and see what we've got here. This came from Banggood, this unit. The official unboxing. Looks like it kind of got banged around the shipment, doesn't it? The box is kind of crushed in the corner, but that's okay. These things are well packed. Here's the unit itself. It's got a stand it up. What else do we have in here? We have a charging cable. And we have a file, and we have some welding material that gets us nickel to spot welded batteries to make battery packs. Hey, we've even got a holder, 18650s, I guess. Looks like for 2 different sizes. Yeah, one of these will fit the standard 18650s, I'm sure. Looks like these could be clipped together if you were working on a bigger pack, but they've just included one in here. But these would be able to buy these and set your cells up, and it'll hold your cells in place while you're working on them. Excellent. We're going to spot weld some cells together. I'll get some of these type of cells here, 18650s, and we'll stand them up in here, and we'll put some together. I so happen that I've got one here, but I've got others. So let's get spot welding and make a little battery pack using this new little spot welder. We'll put the terminals in here. I should probably read the instructions before blowing myself up, but we got a power button on top here. I see what type of charge is in it now. It looks like the battery's got 7.7 volts in it, so it has some charge. Mode. Okay, cylinder cell, nickel plated sheet, thickness. You set up all your parameters here. Alright, so that's how you set it up. I guess it's ready to go. As soon as I touch these probes on, it will sense that they are in place and will zap. Let's grab a couple cells. Let's see if I can zap some strips on them, make a battery pack. Let's grab a few that I've got kicking around here. I used to have a whole bunch of them. I had hundreds of them, and it was in a dead power bank, and I gave it to a friend. I had one cell that was bad, and he ripped all the cells out. I should have kept the cells myself. Could have used them, but he literally gave away like 120 cells. So I guess the first thing we need to do is we need to tell it what we're going to be welding with. So we're going to go through the different modes to get down to mode. Press and hold. Is it this one? No, it's not this one. As we go down to mode, and we tap one of these other ones. Here we go. So smart mode, cylindrical cell, button cell, sheet steel. So it's a cylindrical cell that we're working on, and the sheet is pure nickel plated. That will be this sheet here that I've got, which I don't know whether it's pure nickel or nickel plated. I think this is pure nickel, so we'll treat it as pure nickel. We're going to put the positive terminal on one and the negative terminal on the other. I'm just going to file down what was there before, the ones I pulled off, just to make sure we have a good place to weld it to. And this is the positive terminal on this one. That's the negative terminal. So we'll just set the positive terminal on one and the negative terminal on the other. And we're going to take a piece of this. We'll just cut a little piece off. That should be enough. Sit across here. And we're going to weld these together and see if this thing works. We'll start out and we'll just tack this one down here first. So I'll put a probe on here and I'll put this one here. And that's it. It just did it. Cool. Automatically spot welded. That was simple. No sparks either. We'll do the same on this side here. Put that one down. Put this one on here. There, it just spot welded it. That was pretty cool. We hit it again. Hit it again here. There. Well, that was simple. Sure beats hauling that big one out. The big one I've got is very good, but it's also very big. And kind of overkill when you're just spot welding this type of stuff. That worked out pretty good. Now the other side, we would put our tabs on there, one for our positive and one for our negative, and then we could attach it to our appliance, whatever we were going to put it in. If I get my meter, I think these cells are charged. Might not be, but I'm pretty sure they are. There you go, 5.2 volts. That's a quick demo of this little spot welder. There's not much to it. You turn it on and it's ready to go. It charges up with USB-C. It also can be used as a battery pack, so if I were to plug my phone into it, for example, I could charge my phone. To give you an idea of how well these are attached, let's pull them off. Oh, they're on real good. It actually ripped through the nickel to get that out of there. Yeah, they're welded on really well. I like it. I like it. I'm going to be using this one, I think, when I make battery packs. One, because it's got the holder. I'm going to reuse this piece of nickel because we're going to attach it to a button cell that can be used to replace a dead one in a stereo, like for the backup, because this can do button cells as well. We do that by switching the mode here. Let's cycle around till it says mode, and the type of cell is a button cell. A word of warning, do not trust the presets. So I'm going to grab a button cell and we're going to attach this to a button cell. And then it's ready to go back into a stereo to fix the backup for the radio stations. We'll do one of those. I actually have a stereo here that probably could use one, but we'll attach the battery first. So this battery, I was only able to find one. This is dead. This is CR2450. This came out of my garage door sensor, actually. It tells the system if the door is open or closed. I can remotely close my door. Anyway, it's dead, so we're going to just use this piece of scrap of nickel just to attach it, just to show you guys how it's done. Now, this would be like if you're working on an old stereo, an old radio receiver, tuner, etc. A lot of them use button cells on the display board to back up the memory, and they're pretty much all gone dead these days. And buying the button cells with the leads already attached are expensive. When you go to Amazon and so forth, you can buy them with the tabs already spot welded on, but you're going to pay a lot more for that. One of these units, you can do it yourself and save yourself some cash. So again, same way, we selected button cell in the menu, I just grab the two little probes and say this is nice and convenient because it's battery powered. The other one's great because it plugs in and you can spot weld all day. But most people that are going to use one of these, they only have a limited number of cells that they need to actually work on when they're working on their equipment. You need to spot weld a new tab onto a new battery. It's as simple as just doing that. That shouldn't have done that. It just blew up in my face. That was an electro boom moment. Oh, that wasn't good. We had a fire here, lithium. And the stink from this thing is unbelievable. Time to ventilate. Well, that was definitely going to make it to the highlight reel. I see a new opening. I see a new opening coming. Why did that cell blow up? I mean, it wasn't like there was any excessive, and this is a dead battery at that. But, like, it wasn't like there was any excessive current, and this was switched to button cell, right? Object button cell, as opposed to sheet steel or a cylindrical cell. This was set to a button cell. So why did it blow up? That's interesting. But it went off with a bang, that's for sure. Well, we won't do that again. Maybe I'll use my other one for that. That's weird. This thing, it should not have done that. It should not have blown up that cell. I mean, come on, we're just spot welding it. It wasn't like anything shorted out, and the cell was dead. Like, this is a cell that was taken out of service because it's dead. But it certainly did not like being welded. That's for sure. What must have happened is it must have penetrated. I'm just looking to see whether it actually went through here. It must have penetrated the actual case of it and maybe arced inside. But it shouldn't have done that. That's for sure. Now I'm just using this on the default settings. I haven't switched anything down. It looks like that's what happened. It looks like there's a microscopic hole right here where the probes were touched. It looks like it popped a little hole through there, and I guess that spark ignited what was inside, and we have a lithium explosion. Oh well, now you know what not to do. It's in smart mode, right? It should have the parameters set automatically for the type of cell that we're using. In this case, it was a button cell. I mean, maybe dial this back down for less power, but it was in smart mode, which you would think that smart mode is got it set. Like you can crank this thing up. See, this changes the settings depending on what you're set for. So it should have been set to the correct parameters from the factory, but obviously it was a little bit too hot. Try this on the dead battery. We'll try welding this piece on here. I shut it down to 40 joules now from the default. We'll see if this is enough to weld without punching a hole in the battery. I think that's probably what happened. Was it was set too high. The default was set too high, and it blew a hole in the battery. Now, if only I can find another depleted lithium cell so that we can actually try this and see whether we can do it without it exploding in our face again like before. So let me go and find another dead cell that we can weld some terminals onto and try to not blow ourselves up. I do have another button cell. I'm turning this thing way down because obviously the default mode is, obviously the default mode is too hot, so I've turned it down to 20 joules when dealing with small cells like this. That might be enough. I was just leaving it on smart mode, but obviously the settings were too high. So we'll try attaching this terminal again onto this battery and see whether it'll blow up in my face with 20 joules on it. Hopefully not. I do have my my safety glasses on here, so hopefully this won't go kaboom, but let's just see. There. That's a little better. That time it worked. So yeah, you get one of these things, be sure you turn it down because it's set too high from the factory. And we'll just put another one on the other tab on this battery. This battery actually is not one that's dead. This has got a bit of a charge in it, so we'll make another tab on this. That way I can actually install this in something like a stereo. There we go. Now we got a battery with some tabs that can be, one tab anyway, that can be soldered down to the board to replace the button cell that's failed in a stereo, in the tuner. There. Okay, so that's good. So yeah, be sure you turn this thing down. Now, I think you guys probably want to see what's inside this thing, so let's open it up and see what goodies are in here. If it'll come apart. That I don't know. It might be sealed out, but we'll see. I'm going to go out on a limb and say that there's screws underneath here, which there are. And probably under here. Yeah, there's screws under here too, so let's just remove that and pop out the screws and see what we've got here. It should pop apart. Oh, wonderful. So this is what's inside this unit. It's got our favorite LiPo cells. We love those. Don't stab these with anything. Where the I was suspecting there'd be a good sized capacitor in here, but it's not. It looks like it's just taking it right off the cells. Huh. I was sure there was going to be a good sized cap in here, but I don't see anything. Interesting. I see a 1000 microfarad 16 volt cap. I don't think that's the one that's doing the welding. It's dumping it straight off these cells directly. Yeah, that's pretty neat. I fully expected this to have some type of capacitor, but it's just the terminals right off the batteries themselves. Wow. Looks like there's one terminal here, and the other terminal is beside here. Put the meter on there and measure. I think that's where we're getting the power from. Is one side of this one here. Yeah, 7.7 volts. That's what's being sent to the terminals over here when it turns on. The transistors here kick in to pulse, and just these MOSFETs just kick in and deliver the duration of the pulse for the amount of joules that you want. One battery terminal's under here, and the other battery terminal's there. That's your negative terminal, and the positive terminal, I guess, is that one. Looks like that's what it says here, right? Negative and positive. Yep. So that's all there is to this thing. It's just 4 LiPo cells, and looks like 2 of them in series, and then the 2 of those in parallel. Because you got 4 cells here. They're only putting out 3.7 volts each, so we just got a little over 7 volts here. So, we got 7.4 or 7.2. What was it? What did I measure it at? I wasn't even looking at it. .7 volts. So 2 packs in series, and then the 2 of those in parallel. And it looks like that's what they've done here. Yep, I can see the 2 negative leads here, hooked up here, and then this other one would be the positive lead from this cell and the positive lead from this cell, and these ones are connected in series with it. Looks like that's how they've done it. I'm not going to take this apart any more than this. There's really nothing to see. I don't think if I remove these screws we're going to see anything, but this thing's charged. We got live batteries here. We saw what that little cell did when it exploded. We don't need to have something like this going nuclear on us. So I'm just going to put this back together, put the screws back into it, and we will end this one because this demo is pretty much done. One other thing it has is it has a USB charger on it, so if I turn it on and I plug my USB cord into here, it should charge my phone, which it does. It says charging 48%, 3 hours until full. It says make sure the cable and charger are properly connected. This is not a high current cord, but it is charging. So that way you can use this to charge your phone. If your phone's dead, you can charge your phone up with this. Anyway, that's basically all there is to show. It's a little spot welder for building battery packs. Make sure you read the instructions. Don't do what I did. Don't use it with the default settings, only to find out that the default settings caused the lithium button cell to explode. I was not expecting that. But I think what happened was the current being a little bit too high, it actually punched a hole electrically through the negative terminal and caused a spark inside the battery, which ignited the lithium in there, the small amount of lithium that these cells contain. And that went kaboom. Anyway, you see that those little cells will burn. You can imagine what the bigger ones would do if you set them off. So careful welding. Play safe out there. If you're working with lithium batteries, they demand the ultimate in respect, and I do mean the ultimate in respect. But other things I've done with my spot welder, and this one would be good for that, is, and I don't have it here, but I did show a video on it not that long ago. I had a cordless phone that used AAA size nickel metal hydride, and I went and got some AAA, this is a AA, and I spot welded onto the terminal on the top and on the bottom and put it in the phone, and I've now replaced batteries on like 4 cordless phones. Instead of going to the store and buying a battery pack that already had the plug and everything on there pre-made, spending $25 for a battery pack, I went to the dollar store. I bought a pair of Panasonic's, 2 Panasonic nickel metal hydride batteries for, I think they were $5 for 2. Put some tabs on them and hooked the wiring harness up to it. Phones are good as new, being used constantly, and saved myself some money because $5 is a lot better than 25 or 30 for a pre-made battery pack at the specialty battery store. Anyway, link is in the description. It came from Bang Good. Thanks for watching. We'll catch you in the next one. Bye.